this is the image over here. And for the image, first I should, for example, if I move this to here, and you may come here and by your naked eye, and you can either show on this on the computer screen or by this scope, and either way. So here for this one, if I move toward the left, this lever, and move toward the right, toward the left, you can see it here. And if you move toward the right, and you can see it through here instead of here. You can choose either one only. Okay, so of course, generally, we will use this one, but it has its pros and cons. Basically, it's easier. You don't have to have a look with your eyes. But however, as you can see, if I move the stage, by the way, I like to tell you how to move the stage. There are two wheels over here, and this wheel, the bigger one, please have a look here. The bigger one, if you rotate the bigger one, it will move this way, and you will see that the image will be moved. Okay, and if you rotate the smaller wheel, and it will move left this way. For this one, horizontally and vertically. Okay, you can move it this way. So these two will control different axes. Okay, and this is for the controlling of the focus, which means that the vertical, the Z-axis.
Which one is it, by the way?
This one. There are also two wheels, and the bigger wheel is the course adjustment, which means that it can move the stage vertically faster. Okay. For example, if I intentionally to move here, and because before you load your specimen, basically we tend to move the stage to be the lowest position so that it will not touch the lens over here. So after loading, for example, like this, and then use the bigger wheel to move upward, you will see here that it changed faster. Okay, for example, if you want to have a look about on this one, oops. This is some indentation mark we made before by using the Vickers. This one, and okay, it's about the position supposedly, and then if I want to see the image clearer, and then here using the smaller wheel to fine tune the vertical position, you can see here that you can make it clearer. Fine tuning, for example, this one. Please watch out because the depth of focus. Sometimes in short, we call it DOF, depth of focus. The depth of focus for the optical microscope is short. So it is impossible for you, because for this indentation mark is a concave shape, right? So it is impossible to see clearly, both for the higher surface or the lower surface. All you can do is to choose one. For example, if you want to observe here at the center, and then this will be blurred. And let's see if I want to see it. Okay, you can see here that it looks like it's clearer and a little bit blur for the higher level. So it's up to you whether you which height, altitude you want to you want to observe. So for example, generally we will have a look on the surface, so we will make it the clearest and leave the hole to be a little bit blurred. It's fine. Okay, and when this is done, and then we capture the picture using this one, you can see here there is a camera with a red spot, and click this and it's saved here. And we may click this and it asks you, do you want to show the image? And then yes, and it will go to this one. This is the image we just saved, and it is irrelevant to this one because this is the image for the saved file. Okay. And if you want to go back, just return to the capture because I just moved that, so it's different. And you can see here that there's another spherical. I think it's from the Rockwell indentation marks. And as you can see here, it's not a spherical shape, which shows that probably the indenter has been damaged. Okay, so we can see very clearly that for the Vickers indenter is square, like all these saved before, so it's fine. For this one, it's not fine. You can see here that it looks like it has some kind of crack or broken already, and that is why we compared our results with other companies and found out that it's different. I think it's because the indenter has some kind of damage already. And please watch out that the magnification of the microscope. You can see here that this one is 10 times. As you can see, it is written here, 10x. Maybe you can have a look over here. And there are, you can in fact maximum for the lens over here, you can put maximum 5 different lenses over here. And the smallest magnification for here is 5. You can see here that 5, which is 5 times, and then this is 5 times, and then let's go to this one. This is, oops. Let's see. Which is, I can see. 10. It's written over there. This is 5. This is 10. This is 20. And okay, this is 10. 10 times 10, which is which means that the magnification you see here is 100 times. And if you move to here, 20. Yes. Generally, we will start from the lowest because it's not easy to find what you are observing. I will find maybe okay here. Okay, this is 5 times 10, which is 50. This is 100, and you will see here that it's not clear. It's not clear. So tune the smaller wheel over here. Do not tune the bigger one, because the bigger one is the coarse tuning. So tune it here. You will see here that it's clearer and clearer. Right? Okay, this is for 10 times 10, 100 times of magnification. And we may make it even more, which is this one. For this one, this is 20, this is 10, so this is 200 times. As you can see, blurs again. So to fine tune that, to find the optimal image, the clearest. Okay, this is 20 times 10, 200. And the highest for this one so far, this is 50. I think yes. Over here, it's written here, 50. 50 times 10, which is 500. And the same, every time you zoom in more, you have to tune the image to the clearer, for example. And as you can see, it's not easy to focus, because now the magnification is 500, which is very big for the optical microscope. Basically, the best or the largest magnification for optical microscope so far in the world is about 2000, but it's not easy to achieve. And so 1000 probably is the largest that we commonly use. For this one, it looks like we don't have the 100 length over here. So it's only 50 times 10, which is 500 times for this microscope. And this is how to use it. And as I said, the exposure, last time I didn't watch out about this one. If I move the exposure to here, as you can see, it's darker. So at first it's around here. So it took me some time to get the rhythm. So when I tune the exposure, there's a bar you can pull, and then you can see here that it's brighter, to make the exposure time to be longer. And auto exposure, sometimes it works, but sometimes it's not. So for example, the auto exposure is darker. It's not always the best. So it's up to you. But however, it's easier for you to use the auto exposure. Okay, and then you can choose for this one. You can choose to save the file in different format. And for this one, the default value is file format is .tif, and JPG, BMP, or .raw format you can use. And so you may try by yourself about, for example, image denoising. I don't know whether it works. It looks like it makes no difference. And combine measurement or some others. And in fact, it can measure. You can measure something. For example, if I click this, you can measure for example if you draw a line, and for example if you want to observe how far away of a certain hole or something, and you can measure that. But so far I didn't use that. I suggest you may try yourself to understand how to do it. But for now, if you just, for example, if I click either one, I can draw it, but however I don't know how large it is. So basically for this one, it didn't. It's still there. Okay. Weird.
It just makes you do more than one at the same time.
Because I didn't use that. I don't think that for this one is, or it maybe it's because I don't know how to manipulate. Probably it's because of that. Because so far, from my point of view,